Okay. So we did up to exponential limits. Have you started solving? Have you solved the exercises from your book, textbook, CBSE?
Yes, sir.
Okay.
Yes, I'm done with those.
All right. So they're very basic ones. Of course, there are so many other questions.
So just a thing, since my offline school will be starting from tomorrow,
Okay.
so I have about 2 hours of revision time in school.
Evenings?
Yeah, not in the, it's from 12 to 2. So like if you could give me
Just
some
hold
sort
on.
of assignment or
Just hold on.
something.
I'm on a call. So this is the point I'm making. As x tends to 1, as x tends to 1, from numbers greater than 1, you raise it to a very high power, it tends to infinity. Whereas x tending to 1 from numbers lesser than 1, slightly lesser than 1, then x power infinity tends to 0. Okay. So, so now based on this, there are some very, very important limits. Okay. Very important limits of this form, 1 power infinity. So this an x, the base tending to 1 and the exponent tending to infinity is an indefinite or indeterminate form. This is one of the indeterminate forms. This is one of the indeterminate forms. Okay. So, so now let's do. There are two theorems or two results. Result 1, very important. Um, okay. If limit x tending to a, f of x is same as limit x tending to a, g of x equal to 0, then limit x tending to a 1 plus f of x to the power 1 upon g of x is equal to e power or e power limit x tending to a, f of x upon g of x. Limit x tending to a, f of x upon g of x. So how do you prove this? This is a very important result, by the way. This very important result. So proof is a simple one. Whenever you get exponents, one way to prove is let L, let the limit value be L. Let L be limit x tends to a 1 plus f of x whole to the power 1 by g of x. So this is 1 plus 0 to the power 1 by 0. So 1, this is tending to 1 base. The exponential is tending to 1 by 0, that is infinity. Now it depends how it tends, which type 0 it is, positive or negative. All this we have to see. So the limit can go to 0, the limit can go to infinity, and the limit can go to a constant value. Let us see that. So to prove that, take log on both sides, log to the base e. So you can apply log within the limit, because limit is just a matter of a value approaching. So you get log to the base e of 1 plus f of x to the power 1 upon g of x. So this will be limit x tends to a 1 by g of x into log to the base e 1 plus f of x. Okay. Now to this, I divide by f of x and I multiply by f of x. Now what happens as x tends to a, f of x tends to 0, right? So f of x is tending to 0, g of x is tending to 0. So I get this as limit x tends to a f of x upon g of x. It is 0 by 0 form into this becomes limit f of x as x tends to a, f of x tends to 0 log to the base e 1 plus f of x upon f of x. So what is this? This is limit log of 1 plus x upon x as x tends to 0. This is a standard limit which is equal to 1. So this is equal to 1. So this is log L to the base e is equal to 1. So this implies L is e power limit x tends to a. So log L is this expression. So L will be e power e raised to this expression on the right. So limit x tends to a f of x upon g of x. Okay, so that's the limit value. That's what we want. This is the proof. So now this makes things many results easy. This result is an important one. Based on that, there are many other results. Now, a corollary result or an associate result. Now, if limit x tends to infinity, f of x equal to 1, and limit x tends to a g of x, sorry, if limit x tends to a f of x is 1 and limit x tends to a, g of x is infinity. So then limit x tends to a, f of x to the power g of x. So this is 1 raised to power infinity. It is e power limit x tends to a, f of x minus 1 times g of x. So look at this. This is very important. The previous case, it is both are tending to 0, f of x and g of x. So this is 1 plus 0 raised to the power 1 by 0, infinity. So the final result is e power limit the 0 into 1 by 0. That means 0 into infinity. That makes it indeterminate. Okay. So same here. Now f of x is tending to 1. So we have to make it 0. So basically this one you can prove just like this. This is left hand side is limit x tends to a 1 plus f of x minus 1 to the power g of x. So this is 1 plus 0 form, 1 plus 0, and this is infinity. So limit x tends to e power limit x tends to a, the 0 part 1 plus 0 part. So 0 part times the infinity part. It is simply based on the previous result where it is 1 plus, this was going to 0 and this was going to infinity. So problems. Okay. This is limit x tends to 0, 1 plus x to the power 1 upon x. This, the answer, this is a standard result. Another one is also a standard result. Limit x tends to 0 or x tends to infinity, 1 plus 1 by x to the power x. The value of this is e, because this is e power limit x tends to 0, the 0 part multiplied by the infinity part, the 1 plus 0 in the base and infinity in the exponent. So x and x cancels. You get limit of 1, which is 1. So you get e power 1, which is e. Similarly, you get this as 1 plus 0 to the power infinity. So limit extends to infinity. The 1 plus 0 part times the infinity part. So this cancels, you will get e power 1. Okay, in fact, this is one of the formal definitions. The second one is one of the formal definitions of E. Okay, this talks about a compound interest problem in economics. 1 plus the interest raised to the power a very large number. So how it's a cumulative interest over the years. Okay, so this particular problem, it gives the definition as and this is one of the standard definitions of E. What is a irrational number E? Many times people give this answer: limit x tends to infinity, 1 plus 1 by x whole to the power x. Okay, now let us do another problem. So find limit x tends to 1, logarithm of 3x to the base 3 whole to the power log 3 to the base x. So how will you do this problem? We will write this as limit x tends to 1. This is log a b is log a plus log b. So log 3 to the base 3 plus log x to the base 3 log 3 to the base x. So it is 1 by log x to the base 3. So this is 1. This is 1 plus 0. So you can still further write this 1 plus log x to the base 3 into 1 by log x to the base 3. So this is 1 plus f of x to the power 1 by g of x form. F of x is tending to 0, g of x is tending to 0. As x tends to 1, g of x tends to 0. So the exponent is 1 upon 0. This is e power limit x tends to 1 log x to the base 3 into 1 upon log x to the base 3. This is e power 1, which is equal to e. Okay. All right, got it?
Yes, sir.
So now we'll do further problems. Limit x tends to infinity. X plus 6 by x plus 1 whole power x plus 4. So This is infinity by infinity, and coefficients of x is 1. So this base goes to 1. Base goes to 1, and the exponent goes to infinity. Base 1 and exponent infinity. So you have to use the second result. 1 plus f of x minus 1, because f of x is tending to 1. So the limit will be limit x tends to a, f of x minus 1 into g of x. X tends to infinity. F of x minus 1 into g of x. The pen is not, the scriber pen is not writing properly. There's some issue. There's e power f of x minus 1 times g of x. So you have e power limit x tends to infinity. X plus 6 minus x minus 1. This will be 5 upon x plus 1 into x plus 4. So dividing by x, this is e power limit x tends to infinity, 5 into, divide by x, 1 plus 4 upon x divided by 1 plus 1 upon x. This is e power 5 into 1 plus 0 by 1 plus 0. This is e power 5. This is the answer. Answer is e power 5. Okay, next question. Next question for today. Now evaluate the limit x tending to 0. 1 plus 5x square by 1 plus 3x square whole to the power 1 upon x square. Okay. So now again, this is 1 raised to the power infinity form. How will you do this? By formula, that is e power limit x tends to 0, f of x minus 1 1 upon x square. This will be e power limit x tends to 0, 1 plus 5x square minus 1 minus 3x square. That will be 2x square in the numerator by 1 plus 3x square in the denominator by 1 by x square. Now x is tending to 0. So x square tends to 0. So x square and x square cancels. So we are left with e power limit x tends to 0, 2 upon 1 plus 3x square. Is e power 2 by 1 plus 0, which is e square 2. Okay, e power e square. That's the answer. Okay, so many problems on this type. One more we'll do and then we'll stop. There are so many tricky problems and limits, but I think for us at the first go, this is sufficient. When we do limits again the next year, we'll do more tougher problems. Now limit 1 plus tan square.
Sir, now you will start revision for the boards, right, sir? Started from March.
When is your board exam?
May 1st, sir.
When? May 1st.
Yes, sir.
So you have a lot of time.
Yes, sir. So I was asking when we could start.
For
Because in
CBSE,
college they have started.
for CBSE, they have exams from 21st Feb. Okay. So I have, coordinate, I have a continuity differentiability application of derivatives to be finished for you. And then I have 3D geometry, vectors we have completed.
But vectors is done, sir. Vectors.
3D geometry, I have to do it.
3D geometry is easy, sir. Sir, is it possible to do maxima and minima first?
I'll come to that. Before doing maxima and minima, I have to do differentiation.
Okay.
Okay. You have to go step by step.
Okay.
Okay. So this is e power limit x tends to 0. The 0 part, tan square root x into the infinity part, 1 by 2x. So this is e power limit x tends to 0. This I can write as tan of root x upon root x the whole square into 1 by 2. So this is tan 0 upon 0 form, which tends to 1. So this is e power 1, number tending to 1, into 1 by 2. So this is e power half. So these are problems of this type of limits. Okay, let me see the other types, but any tricky ones. All right. This is sufficient for now. All right, we'll end with limits. Okay. Today I'll stop the class. It's just Kedar and Harshita. I will take class for you tomorrow. The usual time, 11 o'clock. Will that be okay for you?
Yes.